Okay, so today we're going to be talking about significant figures. What significant figures are digits that are important and meaningful to a measurement. When we're making measurements, such as using these rulers here, we're going to be following the rule all known plus one estimated. Okay, so how that will play out is, say we're using ruler A, and we're trying to measure the length of this box right here. On ruler A, we know that it ends somewhere in between 4 and 5. Okay, so we know it's 4 point something for sure. I'm going to estimate this last digit to be 4.8. So this digit right here is my known, and this digit right here is my estimated. Okay, and we're going to say it's a centimeter ruler. Where now, if I measure it using this ruler down here, okay, I can see this ruler has marks every 0.1. So it has 4.1, 2, 3, 4.5, 4.6, 4.7, and it falls somewhere in between 4.8 and 4.9. So I know that it's 4.8 something for sure. Those are my knowns. And then I can estimate that last one. It looks like it's a little closer to the 4.8, so I'm going to say 4.81. Somebody else might read it and estimate that it's 4.80, okay? Or even 4.82, okay? But that's because that's my estimated digit. People are going to get different answers. However, everybody is going to agree at 4.8. Where on this one, some people might estimate it at 4.7 or something like that. That means that this measurement is much more precise. Okay? When different people are measuring it, they are more likely to get the same answer out to however many decimal places. That's what precision refers to. And this is important because these come into play when we're doing calculations. When we're doing calculations, our ending answer can only be as precise as our least precise measurement. So we have to recognize how many significant figures our measurement has and go from there. When looking at measurements, whether they're given to us in a book or whether we made them ourselves, we can tell how precise they are by how many significant figures they have. Non-zero numbers are super easy, okay? They're always going to be significant. Same with zeros in between non-zero numbers, okay? Zeros to the right are always significant if there's a decimal point. If there's not a decimal point, say we had a number like 450, that zero is not significant. We're saying that we estimated that 5. So it might actually be 449 or 451. We're not really sure. We just estimated that one. Okay? It's the zeros to the left that are not significant. Okay? They're for cosmetic purpose or used only to locate where the decimal point is. They don't really contribute much to the actual measurement. So let's start doing some examples. Okay. So say we're given a number like 0.003821. How precise is that? How many significant figures does it have? These zeros to the left are not significant. They're only used to locate the decimal point. So it has 4 sig figs. If, say, this was an answer that we got when I plugged it into the calculator and my least precise measurement only had 2 sig figs, I would have to round this answer. I wouldn't want to lose where the decimal point was because I don't want to change the actual number, but then I would just keep the first 2 significant digits. Since it's a 2 after it, I will keep it at a 3. I won't round it up, so it'd be 0.0083. Okay. This number down here has 1, 2, 3, 4, 5, 6, 7 sig figs. Because these zeros are sandwiched in between non-zero numbers, they are significant. So it has a total of 7 sig figs. If my least precise measurement only had 2 sig figs, I would round this to 230. Okay? Only keeping these 2 sig figs, but not changing the number. 23 is very different than 230. So I just wouldn't put the decimal point there. Okay? This number right here, there's no decimal at the end, so these zeros we're going to assume are just their placeholders. Okay? And this 9 is the last significant digit. Okay? That's the estimated one. So it had 5 sig figs. If I was going to round it to 2 sig figs, it would be closest to 210. And now I realize that that number totally had the comma in the wrong place. I apologize for that. It should have a comma there and there. So it would actually be, fix that, 2,100,000. Okay. This number right here has a decimal point in it. That means that they measured out to this many zeros. That last one is the estimated one. They wouldn't give us 0.0 if they hadn't measured out to that precise measurement. So if I was rounding, it has 1, 2, 3, 4, 5, 6, 7 sig figs. If I was rounding it so that it only had 2, it's closest to 100,000. So I would say 100,000. This does get us into a little bit of trouble because this number looks like it only has 1 sig fig. Sometimes that happens, and always have a lower precision than what you expect. Let's do one more. This number has a decimal, so we wouldn't put these zeros there unless they meant something. Since they're there, they obviously mean something. Therefore, this number also has 6 sig figs. This 0 is just there for cosmetic purposes. If I was rounding it to 2 sig figs, I would keep the 1 and a 5. The number after it is only a 3, so it would just be 0.15. Okay? Okay. So now that we know how to recognize significant figures and how to round to a certain number of sig figs, let me show you the rules for how this plays out in doing the math. Okay. The rules for calculating with significant digits are stated right here. When you're adding or subtracting, you always round to the least decimal places. That's because if you look at this example, this 83.2, that 2 was estimated. Okay? That means that this 6 is also estimated. Because it's a 5 after it, we rounded it up to 0.7, okay, in order to keep these sig figs correct. This number right here, that 7 was estimated. That means that this 3 was estimated. The number after it is a 7, so we rounded up to a 4 and kept the rules for sig figs. Let's do the example problems with that. Oops. Okay, so say I have 2.34 plus 8901. 2.34 plus 8.9201. You just plug it into your calculator. Your calculator will spit out the number 11.2601. Okay? Calculators do not understand sig figs. If we look at this, this 4 right here was estimated in the hundredth place. So that means this 6 is estimated. It's a 0 after it, so we're going to keep it the same. And we would round to that decimal point. So our answer would just be 11.26. Let's look at this example. You plug it into your calculator, or you do the math, minus 3.2, and you will get 1.902. However, we know that this 2 in the tens place, or 10th place, was estimated. That means that this 9 is also estimated. So we want that to be our last digit, and so we would leave it at 1.9. Okay, so now let's look at sorry, I'm trying to move these out of the way. And it is being difficult, of course. New plan. Let's look at the rules for multiplying and dividing. For multiplying and dividing, it is actually even simpler. Okay? Your answer can only be as precise as your least precise answer. So you're always going to round to the number with the least significant digits. Okay? If we're multiplying here, this number only had 2 sig figs, so our answer should only have 2 sig figs. If we're looking here, divided, this one only had 3, this one up here at 6, so we would round our answer to only have 3 sig figs. So let's do the examples. If I have 6.7 times 10.203, 6.7, plug it into your calculator. Calculators do not understand sig figs. They just don't. You get 68.3601. Okay? However, this number right here only had 2 sig figs. So I'm only going to keep these 2 digits. It's a 3 after it, so I'm going to keep it at 8 instead of rounding it up to 9. Erase this, and my answer would be reported as 68. What about this number? 21.52 divided by 4.3. The answer that the calculator spits out is 5.0023 goes on to the end of the calculator. This number only had 2 sig figs, so I only want my answer to have 2 sig figs, so I would report it as 5.0. Okay. So those are the rules for calculating with sig figs. Hopefully that is a little clearer and you got something out of this.